Welcome to GATE 2021 Model Questions and Control Systems. Today's our topic is root laws technique. Let us see the question number 4. The root laws plot of a negative feedback control system is shown below. Determine the value of K for which the negative feedback system time response is non-oscillatory. Okay. Let us diagram and options. Let us go to the solution. So this is a root laws diagram given. And in this root laws diagram, they are asking for us what is the value of K required to get the negative feedback system time response non-oscillatory. First of all, for K equal to 0, what are the 4 closed loop poles are? Nothing but they are open loop poles only. They are given as 0, minus 1.5 plus J1.5, minus 1.5 minus J1.5 and minus 3. For K equal to 0, 2 poles are real axis, but remaining 2 poles are on complex conjugate axis. Hence, for K equal to 0, the response will be compulsory oscillator. That is, damped oscillations will have it. As gain is increasing here, one of this root is moving in this direction, another root is moving in this direction. These two roots are real and distinct, but this pole is departing with minus 90, this pole is departing with plus 90. These two poles will be in complex nature only until for certain gain value. Exactly for one value of gain K, all these 4 poles will exactly meeting where is at minus 1.5. Means all the 4 poles are becoming minus 1.5, minus 1.5, minus 1.5, minus 1.5. This all the 4 roots of the characteristic equation, they are coming on to the real axis at minus 1.5 for particular gain. Here all the roots are real and equal. Hence, the response will be compulsory. When all the roots are on the only real axis, it will be non-oscillatory. For which gain you'll get non-oscillator on oscillator. Means you have to find the value of K where all these 4 roots will meet. That is only your question. And if you observe still above this gain value, which will find it next, above this gain value, again the 4 roots will break and terminate simply with what angles is? One with 45 degrees, another one with 135 degrees, next 225 degrees and 315 degrees. Roots which are going with 45, 135, they'll be complex conjugate plane, and roots going with 225 and 135 and 225 degrees, there also will be complex conjugate. For 45 minus 45 degrees, they'll be in complex conjugate plane only. 135 to 225, they'll be in complex conjugate. Means the response will be still will have damped oscillations only. Whenever the roots comes here, we'll get pure oscillations. Whenever the roots goes to the RHP, you'll get unbounded oscillations. So for getting non-oscillator response, what is the gain required is when all the roots are at minus 1.5, minus 1.5 here, then the response will be non-oscillator. What is the gain required there is, you'll use magnitude criterion to find that gain value. What is the gain required to meet the poles at minus 1.5? Means you have to measure the length from every open loop pole to that root and take product. Divide by the same thing you have to do for zeros if you have it. If you don't have any zeros, you have to divide by 1. So what is the numerator part is product of phasor lengths from open loop poles to that root minus 1.5. What length you'll have from this pole at origin to this root is here is 1.5. What is the length from this pole minus 3 to here minus 1.5 is again 1.5. What is the length from this complex pole from here to here is 1.5. From this conjugate pair pole also, what is the length or distance you'll have it is 1.5. Divide by, since there are no open loop zeros, divide by 1. Wait for a minute. Yes, welcome back. But divide by 1. Hence the answer will be 1.5 whole power 4. For your correct option is D. Thank you.